Well, hello, folks. Welcome to our lecture for Chapter 1. Let me say at the beginning, kind of the purpose of these lectures is not necessarily to just kind of verbalize your chapters for you, while there needs to be some degree of overlap between what you're reading and what I'm saying. That's really not the purpose, so definitely these won't replace that. But instead, I kind of think of learning statistics as akin to painting a room. Right, and that if you want a good paint job, you're going to need multiple layers. And so what I'm basically attempting to do in these lectures is to reiterate some of the highlights, right? The things that I want you to truly sort of get and focus on in the class, and perhaps by kind of going back over those, it'll sort of alert you as to what things you definitely need to make sure that you understand. Okay, so since this is chapter 1, I thought I would sort of begin by the two images that you see presented before you. And perhaps both of these might reflect the way that you have typically thought about a class like this, right? It tends to be sort of confusing. And so one of the first things I want to iterate about this class is that, you won't be doing any hand calculations. All of the calculations that you need to do for this class really ought to be done by the software. And I can't emphasize that enough. Nothing is calculated by hand. It's all about using the software. So each week you will see not only my lecture, but you will also see a tutorial on how to actually use StatCrunch to calculate whatever calculations you have. So you should watch both videos. Okay, but perhaps you can relate this. So hopefully we'll take some of the mystery around. Now, frankly, I think you'll probably have some of these same reactions because it turns out what tends to make a class like this difficult is not the actual calculations. It's understanding them, right? And so even though you won't be doing calculations, you will be trying to kind of make sense of why it is that you're doing what you're doing and what does this all mean. And so the purpose, once again, for these lectures is to really sort of help you with that. Okay, so chapter 1 is our introduction chapter. And so as all introduction chapters attempt to do, it's really trying to orient you to the subject matter and to give you some of the foundations of what we're doing. So the first thing that you're introduced to is this sort of notion of data, right? And data are simply observations that you or somebody else basically records. Generally, when that data is in the form of numbers, well, that works well for statistics. So something like, say, a scale from 1 to 10, something that could be measured in terms of weight, height, distance, etc. Take something like the number of customers, right? All of these things can be translated into numbers. But it's important to know that data isn't just numbers. Data can actually be non-numeric. So for example, data could be a list of song titles that are stored on a computer or ethnicities of each student on campus. So once again, data can be either numerical or can be non-numeric. Okay. Another concept that you're introduced to in this chapter is this sort of idea of variables, right? A variable is a characteristic of people or things. Some examples would be things like a person's gender, the weight of a newborn puppy, the concentration of CO2 in the atmosphere. Okay. The word variable comes from the fact that the measurements vary from data value to data value. So for example, anything that's different about a group of people or a group of things would be a variable, right? Anything that's the same about that same group of people or objects would be a constant, so therefore it's variable. So the idea is that things vary, which is another word for the word difference. Okay, there are two kinds of variables that you're introduced to, right? One is a numerical variables, right? And this attempts to describe the quantities of objects of interest, right? So once again, examples would be things like the weight of an infant, say the number of sexual partners, time to run the mile, right? All of these things can be reflected in numbers. The other type of variable are categorical variables. In this case, it's really an attempt to describe not the quantity, but the quality of the objects of interest. So usually these kind of data values are described in words, something like skin color. right? Or the city in which you were born, or perhaps sort of a list of last names. Once again, each of these are an attempt to locate you within a category rather than to give some sense of a quantity. So let's consider some examples of numerical categorical data, right? So if you look at this table, there's a mixture of both numerical and categorical data here. So for example, numerical, we have age, right, represented as a number. We have the units, or credits, if you will, represented as a number of credits a person has in a particular major, and we have GPA, right, reflected in a number. But we also have categorical variables, right, such as gender, right, male or female, right, those are categories. Your major, right, categories, and then the kind of housing that you live in. You're going to find that your ability to distinguish between numerical and categorical variables is going to be important for much of the stuff that you're going to learn down the road. And so we'll talk a lot more about that in chapter 2. But one of the highlights of this chapter is that you kind of learn to distinguish between numerical and categorical variables. Okay? Another thing that you are learning about is this idea of a distribution, right? So a distribution is really nothing more than a group or collection of data, right? And there's basically three things or three aspects of every distribution that ultimately you will want to be able to describe. The first thing is something called the shape of that distribution, right? And what we sort of mean is sort of whether or not that shape has something called symmetry, right? And so a way of kind of talking about that, and then I'll show you what I'm talking about, but is to ask the question, how many bumps or modes does that distribution have? Okay, and there might be other distinguishing features about a given distribution. Okay. Another thing that we want to know, or our second aspect of a distribution, is the center. Where is the center of that distribution? Which is akin to asking, what's the typical value in our collection of numbers? And then the third thing that we're going to want to know about is the spread, right? And so basically the question is, are all the data close together, or are they spread out? So there you have it. We want to know the shape, we want to know the center, and we want to know the spread. One particular distribution that we actually have a lot of information about is something called the normal distribution. Oftentimes it's simply called the normal curve. And so with respect to our three aspects, we know, for example, that the normal distribution has the following properties. One, it's symmetric, which means it has one lump, right? Two is it's unimodal, right? There's only one mode, there's only one frequent things. Three is that it's mound or bell shape, right? So sometimes the normal curve is called the bell curve for that matter. Okay, so we know these things about it. Okay, in terms of this idea of center, like once again, it has to do with the typical value in a normal curve, right? The center is sort of whatever that sort of middle value would be. Okay, center is usually not a typical value for the middle of a given curve. So we're talking about the center. I think I've lost something here. Oh, okay, there we go. So once again, the center is that typical value. There usually is not a typical value for a bimodal, which means there's two lumps, or something called skewed data. We'll kind of talk about what that is here in a minute, but you'll read about that. So in this case, right, this would be a distribution in which the center there is not a typical value. If you look at that distribution, it's what we mean by bimodal. There's kind of two lumps basically happening in that data. Okay. In terms of the idea of variability, once again, describes how spread out the data values are. And so we have an example on the left where we have very low variability. That means most of the numbers are between 15 and 25. And yet in the image on the right, we have a lot of variability, right? It goes from 10 to basically 60, some even up to 70. So there's a lot of differences between those numbers. Okay, and then the last thing that you're introduced to this chapter that's important is the ability to distinguish between stacked and unstacked data examples from StatCrunch. So if you look at the example of stacked data, notice that each row represents a different person. So we have Steve, and Steve is 23, right? And his weight is 189 pounds, and his height is 73 inches, right? Followed with Maria, who's 17, weighs 113 pounds, 63. So it's called stacked because technically our people are kind of stacked on top of each other. Compare that with what we see down at the bottom, where the data here is unstacked data. So in the second column, where it says time min, we have a number of times for men. So this is some tracked data, right? And so we really have all the men in one column. And then next to it, we have the times for women all in one column, right? So in this case, the individuals are not stacked on top of each other as we have stacked data, but they're really sort of in columns. You'll find that some of the data examples that you'll be working with will be in stacked data format, and some of them will be in unstacked data format. And so you'll need to learn how to use StatCrunch to really kind of do both. Okay, so you might want to look out for that depending upon how the data is presented to you. Okay, so that's going to be all for this week. So hopefully, in addition to watching this video and having read the chapter, and then don't forget to watch the StatCrunch video on how to do these things, right, that will bring about the objectives for this week. Okay, so take care. Bye-bye.